Hello everyone, welcome to Reactify Labs. Today we will do another Leetcode problem called longest valid parentheses. Okay, so this is problem number 32 on Leetcode, and it is tagged as a hard problem. I am not really sure who tagged this problem a hard problem because I don't think this is a hard problem, or I may be doing something wrong. I don't know. My point here is to make a video, so I'm doing that. Okay. Uh, so yeah, let's see what the problem statement says. Okay. Um, and honestly, I don't think this is a hard problem because I don't know why. Because it's so easy. I'll explain you the solution, and you will also say yes, it was quite easy. Okay. Mm, okay, let's start. So, as the problem says, as the problem's name says, it's longest valid parentheses. So you are provided with some parentheses, right? Some things like this. Okay. And in this, you have to tell, okay, you have to tell what is the length of the longest valid parenthesis. Valid as in which is well formed. So this is a valid parenthesis. Okay. This is not a valid parenthesis. Okay. This is not a valid parenthesis. This is not a valid parenthesis, but this is a valid parenthesis. Okay. Again, this is not a valid parenthesis because something is opening, something is closing, but here it is extra. It is closing without an opening. Okay. Similarly, this entire thing has only this valid parenthesis. Okay. So the problem will be like this. I'll talk about the given test cases. So it's like this. So for this, answer is 2. Okay. Because 2 is the length of the longest well formed parenthesis, which is also a valid parenthesis. So this is the 2. Okay. Another test case is this, and this. So here if you see, this in itself is an invalid parenthesis. Okay. This opens, this closes. This is a valid parenthesis, length 2. This opens, this closes. This is again a valid parenthesis, length 2. So if you see, the entire length of valid parenthesis is 2 plus 2, which is 4. Okay. But again, if it was like this, so in this case, again, if you see, this is a valid parenthesis, this is a valid parenthesis, but there is an invalid parenthesis in between. So for this, the answer is 2. So the problem actually again says, given a string, okay, so whatever is given to you, it's a string, okay, and the longest valid parenthesis will be a substring, okay. It has to be a substring. It cannot be a subsequence. Subsequence is this plus this is a subsequence, but substring is, it should be contiguous. Okay. So longest valid parenthesis, which is a substring of that string. Okay. So I hope the question is clear. To test your understanding, let's try on this. What is the answer for this one? So it is opening, it is opening, it is closing. Okay. So we have 2 here. Okay. So for this opening, there is this closing. So now we have 4 here. Okay. And this is closing. So nothing, it breaks here. This is opening, this is opening, this is closing, again 4 here. So for this, answer is 4. But if it was not present here, then the answer would have been 4 and 4, 8. Okay. So again, it depends on what the problem statement is. So yeah, that's it. That's the only problem. Okay. And as the constraint says, the length of the string length can be up to 3 times 10 to the power 4. Okay. So it can be 3 times 10 to the power 4. So it means our linear solution will work, means we can use an order of n solution, we can use order of n log n solution. We can also use n square solution to some extent, but depends on the number of test cases, because if the test cases are, let's say, 100, then it will fail. Okay. Why? I don't know if I have talked about this in my other videos, but we usually suppose that computers do 10 to the power 9 operations per second. Okay. So for 3 into 10 to the power 4 length of string, if we have order of n square, so it will be 9 times 10 to the power 8, which is again less than 10 to the power 9, yes, but sometimes, you know, the other operations that computer takes, it might take 10 to the power 9 seconds. Okay. And usually compiler gives you 1 second to run all the test cases. So if it's 1 second, then of course hardly 1 or 2 test cases run, and usually Leetcode gives, I think, I don't know, sometimes 50, sometimes 2000 test cases. So in that case n square will fail, but n and n log n can work. Okay, cool. Now let's move to the solution. So the solution, as we can see, that we have only two options, n and n log n, and I don't see anything which can be done in n log n because I don't see a binary search coming here. So let's see how what do you say, how it can be done in linear time. Okay, so if you see, let's take the test case again, one of the test cases. So it's 1 2 3 4 5. Okay, we can take this 5, and let's take another test case, which will be 1 2 3 4 5. Okay, whatever we do here, we will do in both. So if you see, if we start from here, if we count only the opening and closing brackets, okay, if we count opening and closing brackets, and whenever open equals close, okay, whenever open equals close, that is our one size, means we know that, okay, that is at least a valid parenthesis. Okay, if open equals close. Okay, but you might say that here open equals close, right? But is it valid? No. So we need to give a check for that also. Okay, if at any point something like this, to handle such kind of condition, we'll need to do something to handle that okay, if at any point this kind of situation comes, we have to make sure that that does not get counted. Okay, so we will use two variables. Okay, oh sorry, I'll keep it here. Okay, we will use two variables, open and close. Okay, so let's start counting. Okay, so open, close. Let's start counting. For this, open becomes 1, again this open becomes 1 more, again this open becomes 1 more, right? Now close becomes 1 and close becomes 1 more, right? So open is 3, close is 2. What do we conclude from here? We conclude nothing. Okay, because we said when open equals to close, only then we will have our answer, right? So since open is not equal to close, we don't have any answer at this moment. Okay, so let's try from the other side. Okay, let's try from the other side. Let's try from this end. Okay, so when we try from this end, we will see again open, close. Let's mark it like this. So this is counting from left side, this is counting from right side. Okay, so open, again this is close now, right? So close is 1, and for this again close is 1. Actually, let me change the color. For this close is 1, for this again close is 1. So now we have 2 close. Okay, now we see, okay, there is an open, so 1, again there is an open, 1. So at this point, if you see, open is also 2, close is also 2. So now we see that, okay, open and close both are 2. So open and close, so our count is 2 times open and close, right? 2 times or just open and open plus close, or 2 times open or close, anything, right? So our answer or length, okay, max length can be whatever we had max till now. We can say max is 0 initially, max or 2 times open. Okay, because open and close are both same, you multiply it with open or close, does not matter. So this will give us our answer. So for this case, what we get is answer as 4, and we got that while counting from right end. If we had counted from the left end, we would not have got our answer. Okay, so that's why we will do counting from both left as well as right. Okay, let's try the same thing here. So let's try with a different color. So again, counting from left, we will see open is 1 and this is close. Close is 1, right? Now in that case, our max length is max of, actually, so it will be max. So this max is max so far, it's just a variable name, don't stress over it. Okay, 2 times open, right? So this will be, answer is 2. So till this point we know that answer is 2. Now again we have open, so now open becomes 2, and now we have again close, so close becomes again 2. Now again open and close are equal, right? Here open and close are equal. So since open and close are equal, we will again say max length equals max of whatever is max right now and 2 times open. So max right now is 2 and 2 times open is 4. What is the max of these two? The max of these two is 4. So for this, counting from the left side, we get our answer as 4, right? So now we again start counting from the right side. So when we count from the right side, we see open, we see close. Okay, we start from here, we see that close is 1. Okay, and as soon as we see that close is 1, okay, we do nothing. Okay, now again we come here, we see that close becomes 2, right? We see close becomes 2, so it's 1 plus 1. Okay, now when we come here, we see open is 1, so we have open is 1, nothing. Again we see close becomes 3, and again open becomes 1. So if you see, while counting from right, we got nothing. It was never the case that open became equal to close. Okay, so we got 0 from that. Okay, but there is one more thing that we have to handle, right? What is that? So what we will handle here is that, see, this case, this and this. Okay, so what do we do now? We start counting from left. So that is where the special case that we need to handle. Okay, so when we are counting from this side, when we are counting from left side, okay, I'll bring a fresh page up for this. So while we are counting from left side, I told you, right, we will do 2 counting, left and right. So when we do counting from left side, as soon as we see an opening bracket, we know that how much far we go on the right, we will never find something which will match this, right? So basically this is an obsolete or useless or good for nothing kind of string character for us, right? So it means that it is useless, it is not worthy of even consideration. So if you see, as soon as we start here, we find that, okay, we need to do open and close. We will see that close becomes 1 and open at this point is still 0, right? So when we move to this point, before moving to this one, we will see that, okay, close has become greater than open, right? Close has become greater than open. If at any point close becomes greater than open, it means that we will never find an open which matches this close, right? So if we are counting from this side and we have this, this. So we know that at some point there might be something which can match them, right? But if there is any this, then we will know that there will never be something which can close this. Like we cannot move this towards the left of it, right? So at any point when close becomes greater than open, we will just make close as 0, okay, and open as also 0. We will fix both of them to 0. Why? Because as I mentioned, if we have something like this, okay, it matches. But as soon as we find any close, any time when close becomes greater than open, it means it breaks the substring here. Anything which comes from here, it will be separate thing from here, right? From this point onwards, it will be separate thing. Till this point is a separate thing. It means it's a breaker. It means for this point, we will have to set close and open to 0. Okay. So in this case, we will do that. We will set close and open to 0. When we find this again, we'll see that okay, open is now 1, close was still 0 because we set close to 0, and now we don't have any answer, right? Even though there is it, we don't have any answer. If let's say we had this, then close is 1, right? In that case, open, close is 1. Now close is greater than open because open is 0. We will set both of them to 0. Now we move here. Now open becomes 1. Now we move here. Close becomes 1. Open and close are there. Our answer is 2. Now we again move here. There is no one closing this. Even though open is 2, close is nothing. Close is still 1. So it means open and close are now not in sync again. So it means we don't do another calculation. So the answer for this is 2. Okay. Similar thing we will do when we do the counting from right side, right? So this was the left counting, and for the right counting, we will do the same thing for this one. So while counting from this end, as soon as we see this, okay, we know that we will never find a this bracket which can close this one, right? Which can close this one. No bracket can close this one. So as soon as we find an open, and as soon as we find open greater than close, which is exact opposite of this, because this was close greater than open. So as soon as we find open greater than close while counting from right side, we will fix both open and close to 0. Okay, and that's how we will get our answer. So whatever answer we get from the left side, we might get answer 1. From right side, we might get answer 2. So our answer will be maximum of answer 1 and answer 2. Okay. Great. So that's it. So if you want the pseudocode, I can give it to you, but I see that I don't have space. Let me write it here. So what I will do is just write a simple pseudocode that write a for loop, okay, for loop starting from left, okay. Similar thing we will do for right also, right. For loop where I will start from 0, and there will be a for loop where I will start from s dot length minus 1. Okay. We will go forward, we will come back, okay. So if string of I is an open bracket, then we will make open plus plus, okay. Otherwise, we will make close plus plus, correct. And if at any point open becomes equal to close, okay, we will update our answer. Answer will be, let's say it is answer 1, will be max of whatever the answer 1 was till now and 2 times open, max of this, okay. And else the case that I mentioned, if close becomes greater than open, at any point close becomes greater than open, we will say that open equal to 0, close equal to 0. Okay. So that's it. Next, again the same thing will go here. We will just copy the same thing here, and the position of open and close, and close will interchange. Okay, you can try that. I hope that works. If it does not, then I have added the solution link code in the description of the video. Please watch that, and hopefully that will work, because that will definitely work. I know it's running fine. Okay. So yeah, this was a small video. Although it was tagged as a hard problem in Leetcode, I told you it was not a hard problem. It did not even take 20 minutes. Okay. So yeah, thanks very much. As usual, have a good day, and please like, share, and subscribe. Thanks. Bye.